repeated. That OPP1 will be on data processing and regression model building. So prepare till week 5. Okay. So everything till week 5 will be sufficient. And it's an easy paper, so if you have done concepts till week 5 well, you will be able to score very good marks in OPP1, and in fact 100 marks only. You should be able to score 100 marks provided you have done all the week 5 till week 5, all the coding part and the processing part, pandas and all you have done well. That should be more than enough. Yeah, Disha, can you go up a little bit? Okay, you are doing the quartiles. Yeah, that is correct. And outliers will be. Yeah, see, your code for outlier looks correct to me. There is some problem in how you are in your data frame. There is some problem. You need to print the data frame 1 or 2 times to see. I think some issue is there in the data frame because the code looks okay.
Sir, where is the issue?
It doesn't look like there is an issue in this cell. Can you go up a little bit, like in the previous cell? Uh, okay, one more. I just want to see the one before it, one before this one. No, one before. Okay, this is working. So train DF is fine then. Okay, now you can go down to the outlier cell. Okay, you have detected features, total square feet, bath and balcony for feature and features. Can you print train DF1 once for me? Print the train DF1. Okay. Yeah, this looks correct to me. This is fine. Show me the error once. Okay, so you are using the upper bound and lower bound. That is fine. That is how we do it. There's no problem in that. Data frame object is not callable. So, like, were you able to get any graph of the data? Like when you were plotting graphs from this data or some EDA, the data frame was working, right?
Yes, sir. Yes, sir.
Okay. This looks correct to me. Like I don't think there is any problem in the way you are going wrong, but probably there is some. You are using the pipe symbol, right? No, 1 second. No, 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 no. Go back to the code. I think there is a symbol error that you are doing, probably. Go back to that cell. I think there is a yeah. So outliers, yeah, this line outliers is equal to train df1. Can you go to this line? So you are actually using the round bracket somewhere and a square bracket after it. So I think that is the problem. Probably you have to use yeah, this one. So can you just go to train df1 and then round bracket train df1, that part? I think there you have to use a square bracket. You have used round bracket by mistake in that, probably. I think that is the error.
Sir, the highlighted part.
Yeah, the highlighted part. Just try with square bracket once instead of the round bracket. I think that is there. I'm not sure, but I think it is the error. Yeah, now run it. Okay, so check the error. Yeah, I think that error is resolved now. That we have resolved because see, this is some different error now. The error that you were getting earlier, that error is basically you are. How do you index a data frame? You do it with square bracket, right? When you have to index a data frame, you index it with square bracket. In like dictionary, right? You index the key of the
Yes,
dictionary
sir.
with. So you were doing it with round brackets. That's why you were getting that error. This is a different thing. This is some problem in the data now. This is a whole different error. That error is resolved now. So now you're getting something different.
Okay, sir.
Yeah, okay. This is something in the code now you have to work on. That error, I hope you understood what I'm telling. I'll just share my screen and show you one so that it's clear what the error was. So whenever you are accessing data, so in pandas, like whenever you are accessing data, how do you access data? You do df of train like this, right? Df train. No, sorry. If you're accessing some feature, like you're doing df train and you want to access some feature, so you access it like this. Okay. But what the problem was, you were accessing this like this. Okay, so this bracket is an issue. So whenever we are indexing something, we should not use this bracket. We should use the sorry, we should not use the round bracket. We should always use the square bracket. That was the error in your code.
Okay, sir.
Okay. Yeah. Actually, that was difficult to spot. Even I got confused there, but that was the error. It was a bracket error. So that's a minor error. The next error which you're getting, that is probably something with the data that is wrong there. So that you have to check the code again and see if the processing is right or not. When is the deadline for this? Like, have you got any fixed deadline for this Kaggle assignment?
Sir, today.
2 weeks. So I think sufficient. You can do it after quiz one, right? Don't give it too much time.
Sir, deadline is today.
Today. Okay.
Yes, sir.
Okay. Sorry, I heard 2 weeks. Okay, so I think it will be fine. The rest of the errors you can go through the documentations and all, and yeah, because you can go through documentations and that should be sufficient. It
Okay,
won't be
sir.
an issue. Okay, anything else? Anyone else has any problem so far in MLP, like in the first 5 weeks? Yeah, Bhupen, Bharat, anything? Vishnu, any issue you have? Yeah, Vishnu is saying something. You can unmute Vishnu. Live streaming is on. Live streaming is on. It is streaming.
Sir, leader. Hello, hello.
Yeah, yeah, Bhupen.
Sir, sir, one doubt is that how to increase a rank on leaderboard in competition
So,
के लिए.
yeah, how to increase your rank? You have to either try building a better model. Like, what model are you using in your first assignment currently? What machine learning model are you using?
Sorry sir, समझा नहीं दोबारा एक बार आप बोलना.
आप अभी कौन सा मॉडल यूज कर रहे हो अपने असाइनमेंट में? मशीन लर्निंग का कौन सा मॉडल आप यूज कर रहे हो सबमिशन करने के लिए?
सर आइडिया नहीं सर मॉडल कौन सा.
नो, यू आर डूइंग, आपने सबमिट कर दिया क्या? कल में हैव यू सबमिटेड?
हाँ सर अभी सबमिट किया, अभी तो 0.55 ही आ रहा है स्कोर.
तो आपने जो सबमिट किया उसमें कौन सा मॉडल यूज किया है सबमिट करने के लिए? दिशा, व्हाट मॉडल हैव यू यूज्ड?
Yes, sir.
What model have you used in the first assignment?
Sir, model selection.
No, I'm asking, have you used regression, some decision tree? What type of model have you used?
सर
Sir,
रिग्रेशन यूज.
regressor, linear
Linear
regressor.
regression, right?
Yes, sir.
So, Bhupen, what have you used? Have you also used that?
सर मैंने रिग्रेशन यूज किया है सर.
कौन सा वाला? Regression में तो there are many models. Which one have you used? Like Disha has used linear regression. आपने कौन सा वाला करा? Can you show me your code, Bhupen, like where you're using the model? If possible, can you share the screen and show me?
सर मैं
Sir,
एक बार लैपटॉप
graphs.
से मैं एक बार हाँ सर लैपटॉप से ज्वाइन करता हूँ अभी.
हाँ, आप जो लैपटॉप से ज्वाइन करके ना, just show me the screen once, okay? Then we'll get a better idea.
Sir, we have to draw all the graphs like histogram, scatter plot.
Yeah, it is better to draw more graphs, like better than like more the better. Yes, try to draw more graphs, like at
Okay,
least
sir.
some variety, like histogram, scatter plot, correlation matrix, something like this should be there. Okay, so for plotting you can use pandas or you can even use Seaborn. That is a very easy library to work with. Seaborn gives you plots in
Yes, sir.
one line. Okay, that is very easy. Okay, I think just tell me. I'll just want all of you to give me now, since we are already 8:13. So tell me, like, if you want me to cover week 5 today, we will do that. Otherwise, because since the quiz is coming, if you want me to cover week 5 later on, that is also okay. So I'll want your opinion on that. If you want me to
So
cover week
I
5, we'll start. Yeah.
think we can cover week 5 in next session.
Yes. Okay, that is okay. Others, what about you? Vishnu, Rahul, you want me to cover week 5 today or in the next session after quiz 1? Okay, no response. Yeah, after. Okay. All right, fine. We'll do it after. Yeah, go down. Dummy regressor you have used. Okay. So, Bhupen, your thing is very simple. You have to use a better model. Currently, you have used dummy regressor. Dummy regressor is a very simple model. आपको decision tree, random forest इस type का कोई model use करना पड़ेगा. With that, you will get better scores. Dummy regressor is just for testing. उससे आपका score अच्छा
अगर
नहीं आएगा.
अगर सर मैं
आप
अगर सर
random
मैं जैसे
forest model
डिसीजन
use
ट्री और
करिए.
रैंडम फॉरेस्ट इसमें अगर ऐड कर दूं, तो मैं जितने जितने मॉडल इसमें ऐड करता रहूंगा उतना मतलब स्कोर ऊपर चले जाएगा।
हाँ, नहीं, जितने मॉडल ऐड करोगे उससे स्कोर ऊपर नहीं जाएगा, बेटर मॉडल ऐड करोगे तो उससे स्कोर ऊपर जाएगा। हर मॉडल का स्कोर अलग होता है। व्हेन यू यूज बेटर मॉडल लाइक रैंडम फॉरेस्ट या डिसीजन ट्री, द स्कोर बिकम्स बेटर इन दैट। ओके, सो आप उसको यूज करो। अभी आपने डमी रिग्रेसर यूज किया। डमी रिग्रेसर बहुत बेसिक है, वो टेस्टिंग के लिए होता है कि कोड वर्क कर रहा है नहीं कर रहा, तो यू हैव टू यूज बेटर मॉडल।
सर तो मैं करता हूँ फिर। ठीक
हाँ,
है।
आप रैंडम फॉरेस्ट यूज
ओके,
करिए।
थैंक
रैंडम
यू।
फॉरेस्ट इज अ वेरी गुड मॉडल, इट गिव्स वेरी गुड रिजल्ट्स इन मोस्ट डेटा, तो आप रैंडम फॉरेस्ट को यूज करिए इसमें। ठीक है, इट्स वेरी सिंपल। रैंडम फॉरेस्ट यूज करना बहुत इजी है। आप उसको ऐड कर दो कोड में और आपका स्कोर बहुत इंप्रूव हो जाएगा उससे। लाइक 80-90 स्कोर
मैं सर
आपका आ
ऐसा भी
जाएगा।
कुछ होता है क्या? मैं ऐसा भी कुछ होता है, मैं हाइपर पैरामीटर अप्लाई कर रहा हूँ तो वो लोड ही लोड हो रहा है, मतलब हाइपर पैरामीटर बहुत टाइम लेता है होने में।
हाँ, बहुत टाइम लगता है। रैंडम फॉरेस्ट एक बहुत बड़ा मॉडल है एक्चुअली, तो उसमें अगर आप हाइपर पैरामीटर ट्यूनिंग करोगे तो वो बहुत बहुत स्लो चलता है। लाइक आई रिमेंबर एटलीस्ट 1 आवर लग सकता है
हाँ,
आपको, उससे भी ज्यादा लग सकता है ट्यून करने में।
मैंने तो 15-20 मिनट्स वेट किया, कुछ हुआ ही नहीं, तो मेरे को लगा ये काम ही नहीं करेगा।
नहीं नहीं, करेगा करेगा, इट इज वेरी स्लो एक्चुअली। वो करेगा पर वो बहुत स्लोली करता है। आप नॉर्मल छोटे लीनियर रिग्रेशन मॉडल वगैरह को ट्यून करोगे तो दैट वर्क्स वेरी क्विकली, बट रैंडम फॉरेस्ट बहुत ही हैवी मॉडल है, तो उसमें बहुत टाइम लगता है उसको ट्यून करने में। उसका एक
तो
हैक
मैं
होता है
करता
कि
हूँ
आप
दोबारा
जीपीयू
ट्यून।
यूज कर लो, पर जीपीयू आई थिंक एमएलपी में अलाउड नहीं है, सो यू कांट डू दैट। तो आपको थोड़ा वेट करना पड़ेगा, बट यू डोंट नीड टू डू ट्यूनिंग राइट नाउ। आप ज्यादा ट्यूनिंग मत करो, आप अभी रैंडम फॉरेस्ट को यूज करके देखो, आपको वैसे ही अच्छा स्कोर मिल जाना चाहिए उससे।
ठीक है सर।
उससे
ठीक
या
है।
आपकी योर रैंक विल बी बेटर वंस यू यूज रैंडम फॉरेस्ट, यू विल बी एबल टू इंप्रूव द रैंक, दैट इज फॉर श्योर।
ठीक है सर। ठीक है सर, स्टॉप कर दूँ स्क्रीन शेयर?
Yeah, you can stop. Yes. Yeah, anyone else? Any other question?
Sir, could you please discuss grid search CV?
Yeah, sure. Okay, so I'm sharing my screen. We'll discuss grids with CV. Okay. So see, what is grid search CV first of all? That whenever you do ML, in any ML model, there are a lot of different parameters, hyperparameters that are available, right? So for example, let's do an end-to-end grid search CV. So let's start with some loading of the dataset and all those things. So you'll get a good recap also. Okay. So first of all, for this thing, we can use the California dataset only, because I think that you have seen right in week 4, California dataset. So that's what we'll use.
Yes, sir.
Okay. So from sklearn dot datasets, import, fetch California housing. Okay. Can you tell me how to load it as the data frame now that we had discussed 2 weeks back also? So can you,
California housing is equal to
so
fetch.
data is equal to, we'll create a class of it, right? So we'll create a
Yes, sir.
class. And then what do we do? Any parameter here? We can do the feature and label like that, right?
Yes, sir.
So x is equal to data dot feature, right? What was it?
Data dot feature name.
No, feature names gives you the columns, right? Okay, let's try it with the other way. So if you don't remember, let's try it with the short way. So what you can do is you can just use this as frame, right? If you remember, there was a second way. So just use
Yes,
as
sir.
frame is equal to true. Both the ways are fine. We discussed the first one 2 weeks back, so I thought we'll discuss the second one today. And then what you can do is you can just say that df, let's call it df, is equal to x dot frame. Sorry, data dot frame. Okay. So when you do this, what happens is this converts the entire data into a data frame straight away. Okay, that is pretty quick. So just when you are loading the data set, you do as frame is equal to true. That will load the data set as a data frame. And then what you do is you do df is equal to data dot frame. So what this will do is it will convert the entire data into a data frame very nicely. So very clean conversion will happen. Okay, the other way was using the feature and column names that we had done last week using the pd.dataframe method. That is pretty long, so you can even use this as a shortcut. Okay. Yeah. Okay, now once we have loaded the data, what is the next step?
Pardon, sir. Sorry. Once can you? I joined late. Can you once data frame?
Yeah, sure.
What do you tell you?
Yeah, so I was saying that whenever we
Yes.
are loading dataset from sklearn, so we are working with the California housing dataset today. So when we load the dataset from sklearn, what we do is first we create a class of the data frame, right? So if you remember, we do fetch California housing and we load it as a class like this, right? But what we need to do is this.
Yeah.
This is an sklearn bunch object, right? If you remember, this is sklearn bunch, not a data frame. So we have to convert this into a
Yeah.
data frame, right? So to do that, we have discussed
Yeah.
one method a few weeks back, which is that pd.dataframe method. But today I just did it with a short
Yeah,
method,
PD.
which is just you do it as
Yeah,
frame
yeah.
is equal to true. This was the second method, right? So once we do it with as
So
frame
what
is
does
equal to
what
true,
does it do? As frame is equal to 2, what does it do?
this converts it into a data frame internally. But to actually get the data frame out, we have to again do a dot frame here to get the actual data frame out. So when I do,
Okay.
so when I do as frame is equal to true, what this will do is this will do convert this bunch into a data frame, but internally you cannot print the data frame. Okay, just with at frame is equal to true. So to print the
Okay.
data frame out of this
Okay.
object, then you do this as frame, the dot frame. Okay, so to print the data frame in your code, to print the data frame in the code. Okay, so first we convert the bunch into the data frame internally with this parameter, but to get the data frame out
Yeah.
as the output, we do this dot frame. Okay, and that actually saves us a lot of time. We
Okay.
get the whole data frame directly, right? So that's pretty neat.
Okay.
Yeah.
Okay. Thank you. Thank you.
So both methods are fine, either the pd.dataframe method that we saw earlier or this method. So both of them you can take, whatever you are comfortable with.
Okay. Okay. Okay.
Okay, so now we have converted the data set into a data frame from a bunch object, right? So what is the next step? Can someone tell me? Like, what do we have to do?
For what purpose?
We are basically trying to build a regression model here where we will
Oh.
take all these features and we will predict the price, which is this label.
Okay.
Yeah. So what do you think we should do here? We should split the features and labels,
First,
right?
yeah. First, we have to
Split them.
separate the labels and index also.
Yeah, index also. By basically we have to, from this df, we have to get x and y, right? X will be the data and y will be the label. That's what we have
Yeah.
to
Yeah.
get.
Yeah.
So can anyone tell me how to get that?
The split.
Yeah, split. No, not the split. We can do the indexing, right? Data frame with pandas, we can do it straightforward, right? So just the dropping. So we can just do x is equal
Yeah.
to df dot drop, right?
Drop.
Yeah.
Name,
So this
names
will
of
drop
the
and we will
columns.
just call columns. Yeah, and then we'll give a list, right? In which we'll just have this name of one column. Okay. So
If it is a list of columns separated by comma.
yes, list of columns separated by comma, and currently we just want to remove this column, so we'll just have one name here in the list.
Okay. Correct.
So this is done. But there is one problem. Now, how do we get y? Can we get y?
Create y. We have to create y.
No, for y actually we can directly get this column, right? We can just filter this column out. So if I just do that y is equal to, I don't need to drop anything, right? For y, I can just do df of medhouseval, right? That will give me y, right? So I
Yeah,
just
this
get
will
this
give
column
it.
from the data frame. Right?
Yeah.
That's pretty easy. Yeah. So for X, we have to drop it. Someone is unmuted, I think. Okay. Yeah, okay. Okay, so now what we have done is we have basically got X and Y. So we'll just see what X and Y are. X is the entire data set with the features, right? And Y is the label. So we have been able to successfully get that. So Y is this label. Okay. So Disha, are you clear with this so far?
Yes, sir.
Yeah, okay. Okay, so now what we have done is we have loaded the dataset and we have converted the dataset into features and labels.
Excuse me, sir.
So what's next then? What do we do after this?
Excuse me, sir.
Yeah,
Sir, can you scroll up a little bit? I have to note something.
yeah, sure.
Add a little bit more. Yes, sir. Here. Thank you. Thank you. It's done.
Yeah, okay. Okay, so we have what we have done is we have loaded the dataset and we have split the dataset into the features and labels. So what do we do next? What should be the next thing that we do? Can we build the model or there is something left before building the model?
Sir, could you please go up? Okay, sir.
Anything left before doing the modeling or we can start the model building process straight away? So you remember
Scaling pre-processing is required. No?
we have to do pre-processing, but these sklearn datasets are pre-processed. We can do scaling. Yeah, scaling we can do. So let's do scaling, right? We can scale the
Scaling is
data.
required,
Yeah,
yes,
so let's
yes.
scale it.
Now, how can we understand that the data is pre-processed?
No, this is actually not pre-processed, but you will see that there is no categorical column inside this. Right?
Okay,
Everything is
okay.
numerical.
On
There
basis
is no
of-
missing value. So all those things are there. But scaling we can do because if you see the values are all different ranges, so we can scale them. That is a good idea. So let's scale the data. So what we'll do is we can take the min-max scaler, right? So or standard scaler, anything which you want. Let's start with min-max only. So from sklearn dot pre-processing, import min max scaler. Okay. So what do we do now? We can call scaler and we can create an object of this, right? Of the min max scaler. So that's what we'll do. And now what to do? Can someone tell me what to do now? How to put the scaler into the data? Like there is a command, right?
By using fit transform.
Yeah, correct. So x is equal to scalar dot fit transform x, right? So what this will do is it will fit the scalar and we will be able to pre-process all the columns. So let's see if x is processed or not. So it is processed, right? So we have converted this into the scale. Everything is between 0 and 1. But the problem is now this is not a data frame anymore. So I have to convert this back into a data frame, right? So can someone tell me how to convert it back into a data frame? Is it required to convert this into a data frame or can we actually work with this also for building the model?
So we can work with this.
We can work, right? Because NumPy array and the data frame, both the methods are okay for fitting a model. So even if you want to fit a model on the NumPy array, it will be fine. You don't need to convert. Conversion is for our visualization. So when we have to see the data right now, we cannot understand what all is given here, right? So to convert our viewing, we have to convert into a data frame. But for building a model, you don't need to. You can actually work with this directly. Okay. So that's the idea. So we have done the processing. So let's now do the model building. Model building. You can also do the splitting of data into train and test, but for now we'll skip that. We'll straight away build the model. Okay. All right. So let's start with the building. So let's build a simple linear regression model. I think that is a good idea. And then we can see some hyperparameter tuning working on that model as well. Okay. So from your week 4, can you tell me what library of sklearn does linear regression lie into? there is a specific library in sklearn inside which linear regression model lies. So can someone tell me the name of that? This is week 4. Week 4 this was covered. So okay. So I think I'll tell
Sir,
you.
could you please repeat the question?
No, I was asking which model, which library of sklearn do we find the linear regression model? That was my question.
Sir,
So
linear
model, right? So sklearn dot linear model, you can import linear regression. Okay. Now, as you remember, we had discussed that while building a ML pipeline, you have many preprocessors like the scalars and imputers, and you have many models like linear regression, decision tree, random forest, etc. But to fit them on the data, the code is very similar, right? So you first import the model, then you create a class of it, and then you do the fit and fit transform. Those things you do, right? So everything is pretty similar when you build any model. So that same thing we'll do for linear regression also. So what we'll do is we'll call linear regression is equal to a class. We'll again create a class of this. Okay. So we create a class of this. And then what we can do is we can straight away fit this model. Again, we'll not transform here because you're not processing the data, right? You're just fitting the model and learning. So what you do is linear dot fit X and Y. So you're going to take the features, you're going to take the labels, sorry, linear reg is the name, and you straight away fit the model with the features and labels. Okay. So let's fit this. And this, whenever you see this blue box with the model in, this means the model has been fit, right? So after fitting, what you can do is you can see that what the scores are, right? So is the fitting good or not? So can you tell me what are the metrics to evaluate linear regression? There are two major metrics.
These blue boxes are not visible in our Jupyter, no? In our notebook in the Kaggle.
I think in Kaggle it's not visible. Yeah.
In the Kaggle it is not visible.
Yeah, in Colab you can
searching for the reply.
No, I think in Kaggle, I don't remember. I think in Kaggle also you can see something. There is some indicator of the model has been built.
Yes, sir, it was there.
Right? Yeah,
visible.
This box was there.
It should be there. Disha, was it there?
Yes,
Yes,
sir.
Kaggle
Yeah,
visible.
it is.
Okay. Okay.
Because this box actually is nothing but an indicator of that the model has been actually fit on the data or not. So that's what this box shows. So I think it in Kaggle it should be there.
It confirms the code is correct.
Confirms the code is correct and confirms that you have built the model correctly, trained the model.
Okay.
Yeah.
Okay. Thank you.
Okay, can you tell me like what are the metrics on which we can evaluate linear regression? Like some metrics that we can use to test whether the model is good or not? From MLT, you must have done in week 4 also, we must have discussed some metrics. So can you give me a name of some metrics we can use to see if the model is good or model is bad?
Root mean square.
Yeah, mean squared error is one. Another one is R2 score. So if you remember, there is a metric.
R2 score.
So R2C, remember it like this. Whenever you have score, like R2 score, there is another one called explained variance score. So all these metrics, whenever you have the metric called score, it should be higher. Okay, so if the score is high, that means the model is good. If the score is low, that means the model is bad. Okay, the second metric is the error, like mean squared error, mean absolute error, and so on. So whenever the error is high, model is bad. So score should be high for a good model, error should be low for a good model. Okay, so this is a trade-off. This you should remember. So how do you get R2 score? R2 score is pretty simple. So what you do is you just call the model and you just do this function called score. Okay, and you again put the data there to score the data, right? Let's see how good the score is. 60%. So this 0.6 means the score is 60%. That means the model is able to understand 60% of the data. That is how I can interpret it. That means the model is not very good, but the model is not very bad either. It's fine. Okay, it's okay. Like not great, but not bad. And for error, what we can do is we can import the error metrics just like we import the models. Score is direct. You can just say dot score and you get the score. For error, you have to import it. Okay, so there is another library in sklearn which is called as metrics. So inside that metrics library, you can find all the errors. Okay, so from sklearn dot metrics import, we can import the mean squared error here. So we'll import mean squared error. Mean squared. So where is mean squared? Here it is. Okay, and then to test the mean squared error, you can just, you don't need to even create a class here. For metrics, it's pretty straightforward. You just write mean squared error and you give the parameters x and y, right? The data. So just give x and y, not the data. Actually, you can't give x and y. You have to give the predictions here. So what you can do is you can give y, and you can give the prediction. So prediction is straightforward. Again, you can just do linear rec dot predict x. So I'll just explain this what I've done. So just first let's just see the error, and then I'll explain what we have done here. So this means that the mean squared error is 0.52. Again, that means the model is pretty average, right? The score is not very high and the error is not very less. That means the model is not doing extremely bad, but the model is not doing great either. Right? It's a very average model, which I have so far. Is the idea clear so far what we are trying to do?
Sir,
The
could you
syntax
please
of the mean
explain?
square error, how it is.
Yeah, I think I heard both of you together. So Shrikant, can you go first?
Syntax of the mean square error, what you parameter
Yeah, that
you
I'll
are using and what
That I'll
what
explain.
other parameters it will accept. Okay.
Yeah, that I will explain. Syntax. Yeah, that I'll just do that in 1 minute. But so far the flow is correct, right? Like you understood the flow, right? We had first built the data, then we had done the pre-processing, then we built a model, and then we saw the metric to see if the model is good or not. That is the whole pipeline, right? So that much is clear to everyone, right?
Yeah.
Yeah. Disha, so far the idea is clear, right?
Yes, sir.
Yeah. Okay. So I'll explain the syntax now. So basically what happens is, if you remember the formula for mean squared error, the formula is mean of y minus y hat square, right? That means the prediction and the label, the true label and the prediction, and you see the difference between them and you square them and then mean the error over all the points. That's how you get it, right? So I cannot actually call the mean squared error on x and y. X is the data and y is the actual label. So it will not be able to calculate this. This will give you an error, right? You cannot calculate this. You have to calculate the mean squared error between the actual label and the predicted label. So what I've done is I've given the actual label here, and to get the predicted label, I'll just call the model, which is linear reg, and I will get the predicted label. So for getting the predicted label, you just have to call this function called predict. Okay. So when you call the function called predict, basically you get the actual label and you get the predicted label. You can even see that. So I'll show you what this actually does. Like even if I
Predict is a keyword of.
Yeah, it is a
Matrix.
keyword of the model, and what it does is it gives you the prediction. Like for that data, what the prediction has been, right? So we can see it like this. So if you see this, these are the predictions for your data, and if you see the actual y, you can compare. So for the first point, the actual y was 4.526, and the prediction of the linear regression is 4.131. Okay.
Okay.
For the second point, the actual is 3.585, and the prediction is 3.976. Okay. So what we can do is we can even plot this as a scatter plot and check as well. Okay. So what we'll do is we'll plot this and we'll see if the scatter plot is perfect or if it's not. And if you see from the scores, it is not perfect, right? I'm not getting a very good score. So there'll be some differences. So what we'll do is we'll do a scatter plot. Yeah, scatter plot of predictions and true labels. So for this, we will use the Seaborn library. Okay, Seaborn is a good visualization library, so we'll use that for this. So import Seaborn, and please explore Seaborn. There is a tutorial given in the lectures as well. Seaborn is very good for visualization, so it will help you a lot in the assignments in the project as well. So what we'll do is sns.scatterplot is the function, and again just give whatever you want to get the plot of. So again, these two things are what we want, right? The actual label and the predictions, right? So we'll do that, and we'll plot a scatter plot of this. Sorry, there has to be a bracket here. Okay, so we got an error here. Scatter plot takes 0 to 1 positional argument, but 2 were given. Okay, that means
first x, second y.
No, I don't think that is the problem. They are saying that it takes 1 positional argument, but I have given 2 positional arguments. But how will I be able to plot with 1 argument? I need 2 things, right? X and y. 1 second, let me try it like this. Yeah, okay. That's how we have to give it. So we have to first say what is going to be on the x-axis and what is going to be on the y-axis. We have to specify that. Okay. Otherwise, it gets confused, like what I'll put on the x-axis and what I'll put on the y-axis. So we have to specify it. Okay, so if you see this scatter plot, can you like what is it trying to say? Can we make some sense out of this? What is this plot showing us?
On
So
the
what is
x-axis, it is showing the actual. On the
actual label
y-axis,
and
is showing the
y-axis is the
predicted.
prediction. So if my
Predicted.
model is perfect, like it predicts the correct thing, what should be the plot look like? Is this how it should look like, or it should be something different?
It should be different.
It should
should
be
be
look like
linear.
It should be linear, right? Because for
Linear.
two,
It should
the
be linear.
prediction is true, actual is true. Prediction is
If
3, actual is 3.
if it is true, then it should be line. All the points should be line on a line.
On a line, right? Absolutely. So here we can see many of the points are actually close to a line, which you can see. That means the model is doing well here. But some points like this 5, on this 5, the model is doing pretty bad. Because you can see for my actual label is 5, but the predictions are random. Some are predicting 2, some are predicting 6, some are predicting 8, and so on, right? So it's doing pretty bad here. Even like in this point, if you see this point, this one, the actual label is something like 1.7 something, but the prediction is over 9, right? So if you see, that's a complete mismatch. So these are the points my model is not doing very well on, and that is why my error metric is showing a very high value of the error. Got it now? Like what's happening? So what I'm
Yes,
doing
ma'am.
again, I'll repeat again. The model, if it's doing very well, the scatter plot between the label and the prediction must be linear, right? Because the label should match the prediction. That's why the model is good, right? But what we see is that the model is not actually doing very well, because for some of the points it is doing good, but for many of the points the label is somewhere very small, but the prediction is too large. The label is 5, prediction is 8. So this is not correct, right? That means the model is not able to learn these parameters pretty well. That is the problem. Okay. So whenever your scores are not coming high, you can plot these scatter plots of the labels and the prediction, and you can see where the model is actually lacking. So here I can see this is one place where the model is actually lacking, this 5. So whenever my house price is high, that is on the highest number 5 in the data set, the model is not able to learn the price well, and there is some ambiguity that the model is facing. Okay. So is the idea clear so far? Any questions on this?
Yes.
Okay. So that is what we did. So that was the first model, that is linear regression. We got a score of 60 and the scatter plot is pretty bad. So what we'll do is we'll now, to improve the scores, there are two ways. One way is you change the hyperparameters of your model. For linear regression, as the model is very simple, changing the hyperparameters may not do a very good job. So the better thing is we try some better model, some heavier model that might learn the data better. Okay. So one model that we can try is, and that model generally does a good job.
Pardon. What you told? Why parameter will not work on this?
No, I'm not saying it will not work. I'm saying that linear regression is a very simple model. So even if you
Okay.
change parameters much, there won't be much of a difference in that. Because
Okay.
linear regression has a limited scope of learning. Changing parameters might make your score from 60 to 65, but it will not give you 90 at any point.
Okay.
So the better thing is the optimized approach is you try a better model. For example, decision tree, and decision tree suppose gives me 85 as my score. So that 85 I'll do a hyperparameter and I'll make it 90. That is better, right? So I'll tune the tree rather than tuning the regressor in that case. Okay. So always the first approach is, before you try any tuning, try a better model. So whenever you try a better, more complicated model, in many times even without tuning, you get a very good score. Then if you want to do tuning, you can do tuning and improve the model even further. But the first approach should always be try a more complicated and better model to make it more optimized. Okay. So again, better model also, there is no guarantee in machine learning. It might be that decision tree gives you an even worse score, but generally in a general trend, it should give something better. Okay. For this data set, the California housing data set, this data set actually is built in such a way that you cannot get a very good score with any model. Okay, so you have to try some deep neural network or something like that to get a good score of this data set. But at least with the complicated models like decision tree and random forest, you get something better than what you get with regression, plain regression. Okay, so that's what we will try now. So is the idea clear what we're trying to do now? Like after taking regression, we are not very happy with the score. So what we are doing is we are trying to use a better and complicated model like a decision tree to make our scores better. Okay. So is that understood so far?
Yes, sir.
Okay. So
Yes, sir.
yeah. So let's now import the decision tree, and we'll again fit it with the same. With the code remains the same, it's just that the model name changes. Okay. So decision tree is inside a library called tree. So you'll do sklearn.tree import decision tree regressor. Okay. So decision tree regressor. So we'll first import it. Again, we'll do the same thing. So let's call it tree here. Tree is equal to, we'll create a class of this. The process remains the same. There is no change in the process. We'll again do the fitting and scoring and all those things, right? Same things. So we'll do tree dot fit x and y. Again, you'll get that blue box, which means the tree has been fit successfully. And then what you can do is you can do the score. Okay, tree dot score x and y. Okay, so what has happened is the tree has got a perfect score. 1 means the score is perfect. So let's see the error. Let's see the error. Let's get the predictions and let's see what mean squared error you get. Okay, let's call this tree. Let's call this a variable only, y predict. So y pred. So this will be tree dot predict. So I'm getting the predictions again. Okay, I'm just storing it in a variable to make it easier. Tree dot predict x. And what we'll do is let's plot the scatter plot. So SNS dot scatter plot y and this one. Okay, so y is equal to y predict. So I think now we can see the difference, right?
Perfect line.
Perfect line. It has learned everything.
What was special in our decision tree, which
See, what actually happens is, if you remember what decision tree does classifications and regressions based on asking questions on the features. Right? We ask chains of questions. Like, for example, if height is less than 5, classify y is equal to 1. If it's greater than 5, then see if weight is greater than 50 or weight is less than 30. Like that, decision tree asks questions at every step, right? So what the decision tree actually does is it tends to grow exponentially. So it asks many questions until it reaches the absolute perfection point. It stops then. So generally, when we use decision tree,
this is overfitted.
This is fully overfitted. When you do it on test data, you will get a very bad score. Yeah, this is fully overfitted.
Yeah, overfitted. Yes.
So what happened here is the tree has memorized your data. Okay. So instead of learning something, learning y is equal to 2x, it has memorized. When y is 2, x is 4. When y is 3, x is 6. It has memorized it like that. That is why you're getting a perfect prediction. So whatever data you're entering, you're getting that particular data in your prediction. So when you try it with unseen data now, you will see that in most cases, it will give you very bad results with unseen data because it is memorized. Like, so it's just like that. You can remember you have memorized week 1 to 4 for MLP OPP, but I test you on week 5. So what will happen? You will not score well.
It is giving one to one result.
Yeah, we can even see the error. So let's see the error. What we are getting, it should be very close to 0, if not perfectly.
Let us see the error.
So y and y. Sorry, y print. Okay, so it's not completely 0, but this is a very small error. Actually, yeah, it is 0. It is completely 0 only. So if you see this e, if you remember, e means it's very close to 0. Right, so the error is 0. It's a 0 error.
E to the power minus 32.
Yeah. E is as it is 10 to the power minus 8, and then I'm doing again minus 32. So it means it's very 0.000 close. It is 0, right? Yes. So the error is also 0. So it's learning perfectly in this case. So once you see the score coming as 1, this means the model has been able to explain the entire data. That means the model is perfect. And this scatter plot, I think, confirms it, right? That the model has been perfect in this case. So yeah, so clear everyone, like what we are trying to do? We are trying to go and make better models so that we get better scores out of those models. Okay, let's try one more model. I think you must have, this is one of the most simplest models in ML. So can you tell me which model I'm talking about? Take a guess. One of the most simplest ML models.
Random forest.
KNN. No, random forest is not that simple because it uses many decision trees inside it. KNN is very simple, right? Because it just has to pick up neighbors and do the thing based on the neighbors, right?
Perceptron.
Perceptron is also simple, but perceptron is more for classification, right? It's not for regression. So we have to use KNN. We'll do KNN. Yeah, perceptron is also a good one. That is also a very simple model, but for classification.
KNN is based on the Euclidean distance.
Yes, Euclidean distance. It will take the nearest neighbors with the distance, and then it will do the classification or regression based on those neighbors, right? So let's take KNN.
It is for classification problems only.
No, for both. For regression also is there. So what happens is when you do classification, KNN, like for example, if I do 3 neighbors, it will see the majority label in the 3 neighbors and it will classify. For example, 2 are blue and 1 is red, it will say the class is blue, right? So when you have regression, it will take the mean of the values of 3 neighbors and that will be your label. So for example, my first house value is 3, second house value is 4, third house value is 5. and I do KNN is neighbors are 3, so KNN will take the mean of 3, 4, and 5 and give you the label, which is 4.
In case of regression, to take mean. In case of
Yeah.
classification, to take voting.
So KNN
majority.
will do, so there are two things. So for regression, when you do KNN regression, you get the mean of the neighbors. Okay. And when you do KNN classification, you take the mode, which is the maximum, right? So take the max or the mode of the neighbors. Okay. So that's the thing. See, actually in MLT, there are many models like decision tree, KNN, random forest. You have done them in the context of classification only, right? But these models can be used for regression also.
You share this collab also, another.
Yeah. I will put it on the calendar. I'll give you the link right now in the chat only, and then again I'll put it on the calendar.
Okay, fine.
Okay, so yeah, that's what I was saying, that all these models that you have learned in MLT, all these models can be used for regression as well. It's not that they can only be used for classification. Okay, so it's the same logic will be used, but in the end, to compute the label, we'll use something different. Like we cannot use mode in regression, right? We have to use some mathematical notation, more mathematical. So we go for mean of the labels in that case. Okay. All right, let's fit the KNN then. Again, fitting KNN is pretty simple. So you have to import it. Again, for importing it, the library is again different. So from sklearn.neighbors, the library is called as neighbors. Yeah, so it has already learned it. So what you need to do is from sklearn.neighbors, you have to import kneighbors regressor. So it's not called KNN here. It is called kneighbors regressor, but that means KNN only. Okay. Next step is again simple. Let's call the model KNN and we'll of course create the class, right? As usual. So let's create the class. But while creating the class, there is one problem. You have to specify to the model, right, how many neighbors you want. Isn't it? You have to tell them, right, whether you want 3 neighbors or 5 neighbors or 10 neighbors or so on to give you the label. Right? So you have to specify this. By default, it will take 5. Yeah. So by default, it will take 5. But if you don't, but by default, it's 5. Otherwise, you can specify how many neighbors you want. Okay, so you just use
if you don't give, then it will take default
5. 5. Default is 5.
Okay.
So is it better to give more neighbors?
See, that is actually the question. Is it better to give more neighbors or is it better to give less neighbors? Again, there is no hard and fast answers. For that, you can actually use hyperparameter tuning. You can find out which neighbor gives you the best score. Right? So you can basically try out with 5 neighbors, 10 neighbors, 15 neighbors, and 20 neighbors, and you can see which k neighbors gives you the best score out of them. Okay, that's where
hyperparameter. This n neighbor is a hyperparameter.
Yeah, because it's not learning the neighbors, right? We are specifying how many neighbors you have to take. So what's the difference between parameter and hyperparameter? Parameter is learned, but hyperparameter has to be specified. Model will not learn it. Okay.
Okay.
Like for example, in random forest, what is happening? You're taking multiple trees, right? But how many trees? 10 trees, 100 trees, 500 trees. We specify it, right? Model does not learn that. So that becomes a hyperparameter in that case. Okay. Yeah. So let's not take 10. We'll start with a smaller value. Let's take this 3 neighbors to start off with. Then we'll see what happens with a bigger value. Okay, we have not run this cell. Okay, now we can just do the fitting and scoring. So knn.fit xy. Okay, and then we can take the score. KNN is a very simple model. Ideally, the score should not be that high. Okay, like decision tree, but we can still see if it does a good job. Better than linear regression, but not as good as the tree, right? So it's a decent score. So if you now see the scatter plot, it will not look like this, but it will be better than this, right? That's the judgment we can make. So let's plot the scatter plot also. So SNS dot scatter. So let's see what we get. So if you see, we are getting it close to a straight line, but there is still some deviation, right? Small deviations are still there. And this final line of 5s, again, this is also not doing well. So if you compare it to the linear regression one, this is definitely better than this one because these bigger deviations like these are not there, but smaller deviations still exist. So it's not perfect, right? And the score also
R2 score is 0.8 something, na, here.
Yeah, so basically this means that 85% of the data it is able to predict well, 15%
go
it's
to
not
the
doing.
in the linear, go to the linear. In the linear
Linear was 60. Yeah, 52. No, 60, 60, 60. 60 is linear.
Thinking like that, this 60 is more better than 80. How it is in the graph of scatter plot?
But we have
60 is not better. 80 is better because see in the graph what is happening is here you can see there are many big deviations here.
Okay, out.
Yeah. But if you see here, deviations are still there, but they are not as big. Those massive
Okay.
deviations are still not there, right? We can see smaller
Okay.
deviations. It is more close to a straight line, if you see.
Okay.
Actually, the score is bad here. It's not more than 90 because this 5 line, this line is still doing bad, right? This end point. I'm not improving here, but the middle point deviations that were there, that I have learned better with KNN. Okay, let's try with a bigger neighbor. Let's try. Let's say with 5. Let's see if it does a good job. Right? So again,
If the data points are creating
yeah.
vertical line, it means at that point of x-axis is doing bad, is it?
Yes, that point is doing bad. Yes, it means higher values of 5. It is doing bad. Those values.
More range is there, right?
More range is there. Yes.
Okay.
So with 5, the score became 80. So just see the scatter plot. It will be a little worse than what is right now, right? Because the score is bad now. Not bad, but little. So you can see some big deviations came in, right? With 80. These bigger deviations were not there in 84. So if you go back to 3, you will see these bigger deviations will disappear and we'll have smaller deviations. So again, we have to fit it first. And now you see the scatter plot, you will see that the deviation sizes are smaller. They're not as big as the previous one. Okay. Yeah, so I think 3 models we have tried. Rest you can do it in the same way. So random forest and all you can try. So again, the idea is same. Just import it from the library, make a class, fit it, and then score it, and then just draw a scatter plot to see how the model is. A scatter plot is optional, of course, but it gives you a good idea of whether a model is doing good on some points or some points it is doing bad. So you get a good comprehensive idea of that, right, with the scatter plot. So that's why it's good to test it with that. Okay, so now we can actually look at the hyperparameter tuning also, what hyperparameter tuning means. So hyperparameter tuning actually is nothing but seeing what value of hyperparameter is best, right? So I showed you a case where we first fit the neighbors as 3 and then we fit the neighbors as 5 and we saw that 3 is doing a better job than 5, right? So if I fit the neighbors as 2, maybe that will do an even better job. So let's try it with that also. So let's try with this and let's see if it does better. So it's even better when neighbors is equal to 2, right? So you got 89 now. So let's see. Almost a straight line, right? So it's better. So basically, there are many hyperparameters that are there in the KNN also. Like for example, one is these n neighbors. So what is the value of n neighbors that you will actually take? Another parameter is the distance. You are computing the Euclidean distance by default. You can even use Manhattan distance or there are cosine distance. There are many other metrics. So what combination of these hyperparameters is best for the model? That is what hyperparameter tuning means. Okay. Now, one way of doing hyperparameter tuning is that you basically do this trial and error. You try with different values and see which is best. But this is very cumbersome, right? It's very far. Like you have to run the model so many times. You have to again change, run. And if you have more parameters like distance and all, you will have a lot of computations to do, and it will waste a lot of time. So to optimize all this into a better way, you'll do the same thing again, but to write lesser code for doing it, there is something called as grid search CV, right? So that actually helps us to do hyperparameter tuning in a much more easier way. Okay. So let's see how grid search actually works. It's a very simple code. And again, for the OPP, there will be questions on grid search. So please practice it and they will have high weightage also. Okay. So please practice grid search well for the OPP as well. So what we'll do is we will first import grid search CV and then we'll see how grid search CV actually works. So grid search CV is imported from a library called as model selection. So from sklearn.model selection, we will import grid search CV. Okay. Now in grid search CV, when you actually create a class of grid search CV, there are many things you have to actually specify inside that class. Okay, so you cannot just directly create the class. You have to specify multiple things inside it. Okay, so to do that, what we have to do is we have to start with the class first. So let's call it grid. So grid is equal to grid search CV. Now inside this class, you have to actually give multiple parameters which are mandatory. and we'll understand why each of these parameters are required. It's pretty understandable. So first thing that is to be required is grid search CV. What it will do is it will tell you what hyperparameters are best for your current model, right? So the first thing that you need to give to grid search CV is your model. You have to tell it what model you are tuning, right? So which is our KNN. So we are tuning this KNN model. So we have to give this KNN model inside grid search CV. So how do you do that? You have you pass this parameter called estimator. Okay, so estimator, and this estimator is your KNN model. Okay, so that is K neighbors regressor. That is the model which you want to tune. After you give your estimator, you have to give the parameters, right? What parameters you want to tune. So what parameters do we want to tune here? We want to tune this n neighbors parameter, right? So what we'll do is we'll create the next thing here, which is called as parameter grid.
Estimator is a keyword.
Yeah, it is a keyword. It's a parameter of this grid search CV. Parameter
Okay.
of this grid search CV. So whenever you create a grid search CV, you will get parameters. So estimator is the first parameter.
And the object we have to give this, right?
Yeah, object we have to give the class, the model we have to give, the model class. Yes, we have to
Okay,
give.
we cannot write KNN here because we have.
We can, but I
defined-
think the problem is if you write KNN is a specific instance, right, where the n neighbors is 2, so it will not be able to tune that. It has to take the general model.
And
Because
suppose we
KNN
name this KNN is equal to only that, then we can give it.
Then
right?
we can give that. Yes. Then it's okay. Then we can give, because
okay.
right now it is specified already, right? Because it's 2, so it will not tune it. But if
Yeah,
it's
here
plain
it is
K neighbors,
there.
then we can give KNN. Yes, that we can do.
Okay.
Okay, the next parameter that is the most important one, that is called as param grid. So what param grid means? Param grid is actually it's a dictionary, and what it contains is, so I'll tell you first how it looks like, then we will come to the code. So what param grid means, it's actually a dictionary. Okay, and what does a dictionary contain? Sorry, this dictionary basically contains all the parameters and whatever values of the parameters you want to tune in. So for example, we have the n neighbors parameter, and we will try all these values in it. Okay, so the idea is whenever you have a param grid, it is a dictionary, and the dictionary contains the parameter that you want to hyperparameter tune, and then what all values of that parameter you want to try. So basically this means I want to try the KNN with n neighbors is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can have the next parameter called distance, right? So distance, and this parameter will contain two values again. One is Euclidean and one is Manhattan, right? That means this grid search CV will try this entire thing on Euclidean distance and Manhattan distance, right? So here will be Manhattan. So all the parameters and all the values that you want to tune using for the model, that you will select using the grid search CV with this parameter grid. Okay. So currently what I want is I just want to tune the n neighbors parameter, right? So what I'll do is I'll just place this n neighbors parameter inside this dictionary here, and that will guide grid search CV that you take this k neighbors regressor model and you take the parameter grid with this n neighbors and all these parameter values for n neighbors. So what it will do internally is it will take, for the first run, it will take k neighbors with k is equal to 1, then it will take k neighbors with k is equal to 2, then k neighbors with k is equal to 3, and in the end k neighbors with k is equal to 10. So iteratively, one by one, it will go and it will fit the model one by one and see which model is the best. Okay, so is the param grid clear to everyone? Any question on this?
This is without data it will do?
No, we'll specify the data also, right? After this, we'll fit the grid search. So grid search will also fit on X and Y. That will get the data there, right?
This grid is an object only.
So we are creating, So like you were creating the objects here, right? So we created an object like this. So we have
like
created
KNN,
an object like this,
like
KNN, but instead of this one parameter, we have multiple specific parameters that we have to put inside the grid. So that's why it looks big.
Grid search.
Yeah. But in the end, it's just the model. Consider it as a model object only, similar to that. One more parameter we have to specify, that is called as CV. So CV basically means cross validation, but for the for the purpose of grid search, you can just remember it as how many times I want the grid search to happen, like how many times I want it to repeat. Okay, so that will basically fit it multiple times to just avoid any bias in the data, right? It's not a mandatory parameter, you can even skip it, but sometimes the code might give you error. I'm not sure whether it will give you error if you skip it or not, but it's better to provide it. Okay. In the OPP, we'll tell you what CV to take. So if you take cross validation as 5, so that means you will have to take the CV value as 5.
Sir, what does CV do?
CV basically divides your data set into multiple subsets, and it will fit the model on random subsets each time. So for example, if I have a data like this, like suppose my data is like this, AAA, and I write CV is equal to 3. So it will split the data into 3 subsets, first A, second A, and third A. Then what it will do is it will take this first model, that is KNN with n neighbors is 1. It will fit it on one of these A's. Second model of KNN on n is equal to 2, it will fit it on one of the other A's. Right? So randomly it will fit the model on some subsets of the data to avoid any bias in the model. That's the idea.
Randomization of the subset of the data, right?
Yeah. So CV means you divide the data into those many subsets, and then each of the model during the grid search will fit on one or other of the subsets. One more method is, that is a different thing, not the default one, is that if you put CV is equal to 3, you add some more parameters, then each of the model will fit on all the subsets, and you will take the mean of the final score of all the subsets. That also you can do. But generally what happens is first one goes here, second one goes here. So even those type of randomness can also occur when you do the CV. Again, not very crucial at this point, but it again, I think in grid search we have to specify it, and in the OPP also, I will, in the question it will be given that you take CV is equal to 5 or 7, whatever. So you have to specify. That's why I added it here.
Okay.
Okay. Yeah.
Yes.
So I think with that the grid search is ready. So yeah, grid is ready. So now what we'll do is grid search is there. So we'll just fit it, right? So grid is also just like a model, multiple models inside this other. So you can see there are 10 models, right? So KNN with 1 and KNN with 10. So 10 models you have, and grid will fit all of these models on the data. So grid dot fit X and Y. This will be slow because it is fitting 10 models, right? So it will take some time. So many a times, even in your assignment, I think someone was asking at the beginning also, right, that it was taking a lot of time to do grid search because it is very slow. Because there are many models and many parameters that you have to tune, so that takes some time. With KNN, it will happen faster, but with decision tree and random forest and all, it will be even slower than this. So don't worry if it's taking a lot of time to run. It's not wrong, but it's just that it is working slowly. Okay. So now that we have fit the grid search, we have, what is next? What do you think we have to do after this? Grid search is ready, but is our work done? Do we have to do something else?
We have to select the best one, no? Best.
We have to
estimator,
see which is the best, right? From this grid search, we have to find out which is the best. So how do you do
have
that?
to find the result.
Yeah, find the result. Like which value of n neighbors is the best out of all this. So how do we get that? You simply do grid dot best params. Okay, so best estimator or best params, both will give you the same thing. So let's call best estimator. So when you call grid dot best estimator, you get the best model, which is KNN with n neighbors is equal to 10. This is the best model from grid search. How do you see if it's the best model? Can we see the score also? We can even see the score. So what you can do is you can do grid dot best score. That will basically give you the score of this n neighbors is equal to 10. Okay, this is not.
This is with this data.
Yeah, this is with this data only. You're getting a score of 48.
So now our model is grid.
Grid, yeah, model is grid, and you are able to see the scores of all different n neighbors with this grid search. Grid is the model. Okay, so grid is the new model. So basically, grid is not the model is stored in the grid. That's the idea. Grid is not your model is still KNN, but that is stored inside the grid.
Correct. Grid is the anonymous name.
Yeah, anonymous name inside which the model gets stored. Oh, sorry, I deleted cell by mistake. It's okay. One more parameter is quite useful. So that is called grid dot best params. Again, that is the same as best estimator. It's just that it will just give you the parameter directly instead of giving the whole model name and everything. So that you get the information directly. That is 10. So when you use n neighbors as 10, you get the best model. When you do best estimator, you get the entire model name only, but you already know, right? It's a KNN model. So you can even do best params and just see the parameter value, which gives you the best score.
But the score was coming, it was only 0.48.
Yeah, it was 0.48.
But earlier we were getting something 81.
Good score.
Yeah, that is because of the cross validation actually. In the cross validation, we are fitting the data on random subsets, right? So while fitting it on the subsets, the 48 was the best out of all this. So this 2, which was on the entire data,
it will change every time.
Yeah, it will change every time. Yes, it will change every time because we are doing randomly.
Run it.
No, this one will not change. No. It's not like that. This one will not change because when you have given the grid specifically, now the random subsets have been mapped. So in the first run, there was random subsets. Now, anytime you run it, the subsets will be same, probably. So let's run it and see it as well. I think it will be the same again. So, sorry, we have to fit it again. The randomness happens in the first run for the same grid. When you run it in the second time, the same subsets get mapped again. So on the first run, you have to get the random subsets. I think that is how it does. Yeah, the same thing. So if you see the score again, grid dot best score. Yeah, same thing. So what happened was your cross validation. What it did was for
And
the first
one
run.
runs
Yeah.
one again. The grid run again run.
This one.
Random search. Yeah.
Yeah,
Run
sure.
again. And they do it. It will change or not?
No, it will not change. It will not
It will change.
It will not change. It will not change. It will not change because
So what is the meaning of CV is equal to 5?
CV is equal to
Yeah,
5.
same.
CC. The idea is it divides it into 5 subsets and it fits each model on a random subset. But once you have done it for the first time, then it will be the same. When you run the grid for the first time, the random assignments happen, but for all the subsequent iterations, the assignments remain the same.
Okay.
So basically, for example, in the first iteration, I got that n neighbors is equal to 1. This got fit on subset 4. So this got fit on S4. Second one got fit on S3. Third one would fit on S2 and so on. S2 and so on. In the next subsequent iterations, it will remain the same. So the randomness has been assigned in the first iteration. For all the iterations after this, the score will remain the same.
Okay.
So you have to create a new grid. Next time you have to work with this, you have to create a new grid to see more random assignments. Okay, that's the thing. So the randomness happens only in the first iteration, not in the iterations after that.
Suppose we create one grid 1 again with the same parameters, then what will happen?
When you create with the same parameters again, randomness will happen, but that again depends. If you get the same assignments, you might get the same assignments also. You might get different assignments also, but that time you can get different. But when you run the same grid, then it will be same always.
Okay, we'll try.
Yeah, please try that. But for the same grid, like this particular grid will give you the same assignments for all iterations. Okay.
Okay.
Yeah. Okay. So that was about this grid. So do you want me to show random forest also, or will you try that yourself?
No, sir. Please. Once again, we will repeat everything again.
Yeah. But if you want, I can just quickly show the random forest also, because random forest is something that you need to work with in the OPP as well. Should I show it? It's the same thing all over again.
Yes, sir.
We'll show it once. Okay. Same thing, nothing different. So that will be from sklearn .ensemble import random forest regressor. The use of random forest is random forest does not overfit. So in decision tree, the problem is decision tree overfits on the training data and we don't get very good scores in the testing data. But when we use random forest, we don't overfit. So in your training data, you will not get scores of 1 and 100. You will not get perfect scores. But when you run it on the testing data again, the scores will still be good. Okay, so the overfitting problem or decision tree, that is sorted from the random forest. Okay. So let's create the class of random forest. So let's call it forest is equal to random forest regressor. And we will fit this now, forest dot fit x and y. Random forest works slightly slowly, so you have to wait for some time. And when you do grid search on random forest, it will be very slow. So that you have to bear with. Sometimes hyperparameter tuning on random forest will take some hours also. So that is also pretty normal, but don't panic if that happens in OPP. It will not happen. We'll not give you tuning for random forest, but it will be fast in the OPP. But in your project and all those things, it might take time. So that's okay. Okay, that's fit now. So let's see the score. So forest dot score x and y. So that's still a good score. It's not a perfect score. It's very good. But the advantage is when you do the train test split, your training and testing score both will be good with random forest. But decision tree, the training score is very good, but testing score is not that good because it memorizes. Random forest is not memorized because see, if it memorized, the score would have been perfect 1, right? It's not perfect 1. So it has not memorized it. It has generalized it rather than memorizing it. So when you do the train test split and you run it on testing data after training, you will still get a good score with forest. With the decision tree, you will not get a very good score with the testing data. Okay. I think this has been covered in the MLT course in detail. So the overfitting, underfitting. So I'll assume that is pretty clear, right? If you have a doubt, we can discuss on that, but I think that should be clear. clear to everyone if you have done MLT.
Yes, sir.
Yeah. Okay. So that was about random forest. One more model that you can try. I'll just name a few models which you can try at home later. So one is AdaBoost. So this also I think in MLT you have seen this, the boosting regressor, right? One is XGBoost. And one is the MLP regressor, which is the neural network, right? You can even build neural network with sklearn. So that is called as MLP regressor. And SVM is also there, support vector machine. So try these 4 models later on. You will be able to see how these work, and these are also pretty powerful. So in your project and in your assignments and all, you can use these models, and they will generally do a good job. Random forest, AdaBoost, XGBoost, MLP regressor, these are very good models. You can work with them and get some crucial results from them.
Okay, sir.
Sir, I have a doubt.
Yeah.
When we have multiple data, such as many CSV files, so how to tackle that?
You have to merge them into one data. So if you remember, if you were in the week 1 Pandas sessions, we learned a command called pd.concat. So what this does is it concatenates multiple datas into one data. So data 1, data 2. So when you run pd.concat, what will happen is, suppose your data 1 contains 5 rows and data 2 contains the next 5 rows. After concatenation, all the 10 rows will be together in one data. So if you have multiple CSV files, what you do is you convert all of them into data frames using the pd.read CSV, right? You convert everything into a data frame. And after, in the end, how many data frames you have, you just run this pd.concat, name all the data frames inside that, and you will get the final full data frame inside it. Okay?
Okay.
Yeah. So how many you have? Like how many files are there?
8.
8. So that means you will do df1, df2 till df8, right? So till df8. So in the end, you will have df8. So what, after running this command, you can then store them in final df. So your df which will be there, this will contain the concatenated data of all the 8 data frames. You'll be able to merge them into one. Okay.
Okay, sir.
Yeah. So pd.concat, simple command. So run them, first convert all the files into data frame by pd.read CSV, and then you do the concatenation, and you will be able to get everything in the same file after that. So this is, I think, in the project, right? This time they have given multiple files.
Yes, sir.
Yeah. So that you can do.
And also, sir, can you guide us on how to perform OPP and what will be the format of OPP?
So yeah, so format of OPP will be, you will have around 18 questions in the OPP. I had planned on 20 initially, but then some of them were longer, so I gave 18 in the end. So first 8 to 9 questions will be on pre-processing, where you will have a messy CSV file. Messy in the sense there'll be missing values, there'll be no scaling, there'll be words, right, categorical columns, and you have to clean it. So how will you clean it? You will fill the missing values, you will do scaling, standard scaling and all that on the numbers. Then on the categorical columns, you will encode them and convert them into numerical columns. So all those things you will do.
One question will have one job, no? Or multiple job, like our Kaggle.
One question might have multiple jobs also, but it will test one thing only. Like, for example, the question might ask you that first convert the categorical feature into numerical feature and then scale it, and then give me the mean of it. Right? That can be one question.
A step will be given. What to do exactly?
Yeah, steps will be given. So whatever has to be done will be given in order. You have to follow the same order. So for example, in the question I have mentioned, first fill the missing value, then scale it. So you cannot scale and fill. You have to fill and scale. Okay?
Got it. The sequence we have to follow.
Sequence you have to follow. Everything is clearly mentioned. You just have to convert the text into the code. That's all. Okay.
PYQs are also there with us.
I think they're not there in, like, there are no answer keys released, but you can find it if you have from some students, if the PYQs in some groups. If they have, they can share it, like the question paper and all that might be there.
Okay.
But you don't need it. To be honest, you don't need it. If you have followed the live sessions, it is sufficient. You don't need the PYQ.
Okay, thank you.
And I will conduct a revision session also. So in that, I will do the full flow with you, like how a messy data will be cleaned, then what type of model building we can do. So I'll do a quick recap of that. That will be sufficient for the OPP. So on the Monday session in the week of the OPP, we'll do that so that you get 7 days to revise it also. Okay? That will be a good job.
Yes, sir. Revision is required for that, because practice very much required in this.
You have to practice. Practice
we do it, we remember it, but again we forget it. When we go to the next week, we forget the previous week.
The paper
We have to
is
revise
very
all the
simple.
weeks at a time.
The paper is very simple. It's one of the most simplest MLP papers this time. Okay, I've kept it very simple. It's just that if you've practiced and if you've followed all the things well, you will be getting 100 marks for sure. Okay. So aim for 100 marks
Okay.
because it is really easy. It is not very complicated.
sir.
Everything is clearly given in the instructions. You just have to convert the instructions into code. That's all.
Okay, sir. Thank you.
Yeah.
Okay.
And please practice pandas, because for pandas it's not going to be that like straightforward. Like you just have to do df.head.tail. It has to be some involvement, right? So you have to think of what pandas function to use well. So that has to be practiced very well. So week 1 is very crucial. Model building.
That's why I requested, sir, in the last session, I think last session, a list of that. What should we revive? What should we make practice? In the pandas, we just do 2 or 3 things.
Go through the assignments of week 1 that test pandas pretty well, and go through the live session collab of week 1. That should be sufficient.
Okay.
Okay, but assignment is important. You have to practice the assignment, because assignment tells you how to solve the question using pandas, right? So that has to be practiced.
Yeah.
Okay.
Okay.
Yeah, that is the first part of the OPP, which is going to be the cleaning and pre-processing. In the second part, you will get a clean data set and you have to build models in like that, like what we have done today. You have to build models. You have to somewhere you have to report mean square error. Somewhere you have to report R2 score. Somewhere you have to do hyperparameter tuning and get the best parameters. So whatever we have done today, that you have to do. Again, the OPP will involve multiple models, at least 6 to 8 models I will be asking, but all of them are same, right? So there's nothing different in any of them. The code is same for every, it's just that importing them and naming them is different. Rest everything is same, right?
Yes,
so you have to do similar things, and then there'll be some hyperparameter tuning somewhere, some mean calculation somewhere. So very simple things, pretty simple. Those won't be difficult. I'll tell you, if you find something difficult, that might be the cleaning part due to pandas, lack of practice in pandas. So that's why practice pandas, and that part will also be easy. The sklearn part will be very simple, straightforward. And both the parts will have 50-50 weightage. So 50 marks for the cleaning and 50 marks for the model building. Okay. And it'll be like you can solve it and revise it also. You will not have any problem in the time and all. That will be there. Sufficient time is there to solve it.
Okay.
Okay. Yeah. So yeah, that was it. So yeah, any other question?
The 8 questions are related to pre-processing and other than.
First 8 to 10 questions will be on statistics and pre-processing. Statistics in the sense you have to calculate something from the data, right? So for example, I give you marks of 10 students. What is the average marks? That can be a question, right? So those type of questions, and pre-processing, which will be basically encoding, scaling, and imputing. Those 3 major things that we have seen. Pipelines and all you can use again to make things easier, but that's your choice. Then after this pre-processing, you will have model building, where you will be given a new clean data set, which will not have any missing value. Scaling and all will be done. And on that, you can directly do the train test split and then build different models, right? Regression, then decision tree, random forest, neural network, all those things you can build. Okay, only those models which are covered in the lectures. No other model will be asked. More or less, we cover all the models in the lectures only, right? So whatever I have written today in the session, all these models, prepare all these, right? And the ones that I showed you, that will be sufficient.
Okay, sir.
And grid search is going to be important. Like grid search will contain a 15 to 17 mark weightage. So please practice grid search well. Okay, again, grid search is same as what I showed you today, nothing else in it. It's just that the parameter grid can be larger. You can have multiple parameters. Like in KNN, we just did the neighbors, right? So alongside neighbors, you can even do the distance, Euclidean or Manhattan. So I'll give you one more parameter. So I can give you multiple parameters that will be mentioned in the question. It's just that you should know how to work with it. Okay. Vishnu, it will be in the YouTube channel as well as in the calendar. You can find the recording in calendar also, and it will be there in the YouTube channel also. It is streamed on YouTube, so I'm streaming it. See, this is streamed. Okay. Yeah. Okay. So Disha, clear about the pattern?
Yes, sir.
Yeah. Okay. So I'll want all of you to aim for 100 marks because it is achievable, very well achievable in the OPP. So aim for 100 so that you boost your grade straight away, right? That will be very good. Okay. Yeah. Any other question? Otherwise, we can wrap up. That was all from week 5. Week 5 was actually just a recap of week 4 only, but with different models. And actually, there is nothing in the models from the sklearn side. Sklearn has all the models in the same code. It's just that the idea of the model, which you have covered in MLT, right? That is important to understand what model actually works as how. Right? That you already know from the MLT course, so that should not be a problem. Okay, so I'll not take more time because you have a quiz one coming as well, so you can prepare for that now. I'll not take more time for today's session. In the
Up
next
to what
session,
week is the PP will cover? Up to week
5,
6.
5, 5, 5 till 5.
Week 5 only. Okay.
Yeah, till
Okay,
this part, till the regression. Only regression will be asked.
Okay,
Classification will
we
be covered
target-
in the next paper.
Okay.
So basically, if you go through week 1 collabs, week 2 collabs, week 3 and week 4 and 5 are actually the same thing only with multiple models and all. So if you would do 1, 2, 3, 5 well, that will be more than enough. I'll still stress that focus on week 1 the most, because week 1 is the pandas part and that is where the mistakes are possible. 2, 3, 4, 5 are very straightforward. We do all the same things. There is no difference in the code, no matter what the data set is. But pandas part, the logic, to build the logic on pandas, that will take some practice. So practice the assignments, and if required, I will, in the revision session, I will take up some question-based practice for pandas as well. That we can do. Okay, so pandas
there
is
is
the
You
main.
can do practice on the pandas practice.
Yeah, pandas practice. I will do it on the revision session. We'll take some questions on pandas because this sklearn part is same, so we don't need to go over it again and again. The pandas part I will cover again for practice, like how to solve questions, like how to identify which function to be used where. Right, that we will practice.
Okay, sir.
Sir, when is the OPP scheduled?
I think on 8th it is, right? 8th November.
Yes, sir.
Yeah, 8th November. So you have 2 weeks after the quiz, enough time to prepare.
Okay, sir.
Okay, but start the practice after the quiz itself, okay? Because so that you get as much of practice as possible.
Okay, sir.
Okay.
Thank you.
Okay, sure. Yeah, any other
Thank you.
question?
Thank
Otherwise,
you.
yeah. Thank you so much, everyone. Then okay, then we'll wrap up for today, and in the next session, we
Wrapping.
will cover the-
Are you wrapping us? Okay. Good night.
yeah. Good night, everyone. All the best for your quiz one. All the best.
Okay.
Thank you.
Thank you, sir.
Good night.